name is Kim Cassida. I'm the forage and cover crop specialist at Michigan State University. I'm going to be talking to you today about a new type of variety trial that we're doing at MSU. In 2018, we began doing testing of cover crop varieties. The goals of these are a little bit different than our typical forage variety testing because cover crops are used for different purposes. But we felt it was important to get some information for growers that would address which of these species and varieties are most well adapted here. We've gotten a lot of requests over the years from seed distributors to run this kind of a test. So this is a bit of a work in progress on how to go about doing it, but this is what we have done for the first year. The measurements that we are collecting include biomass. This is done from hand-clipped samples on one section of the plot because we can't remove the biomass from the entire plot. That turns it into a forage trial instead of a cover crop where we want to leave the biomass there over the winter to be able to monitor what it does in the spring. The biomass is measured twice, once in the fall after a killing frost. We figure that will give us the maximum biomass potential that that crop could give, and then we will measure it again in the spring right before we terminate the cover crops, any of them that overwinter. So overwintering is one of the factors we will also be looking at. We're measuring ground cover using a phone app that takes a picture of the plot and actually measures the percentage of green pixels in the picture. And this is done at 38 and 60 days after planting, and then again in the spring right before termination. Weed control is taken as a visual rating compared to a fallow plot, which has no cover crop on it, to represent the weed potential of the site. This is again done at the same time as the ground covers are done. The winter survival is a visual rating done in the spring at the same time that we do the ground cover rating in spring. And we also will be rating the percentage of dead residue cover on the ground using the ground cover pictures in the spring. And lastly, we will terminate the cover crops using appropriate herbicides, and then 2 weeks after termination we will do a visual rating to evaluate the ease of kill of these species with the herbicide that's used. In 2018, our site was done at the Kellogg Biological Station in Hickory Corners. Public entries were invited at the university set rate of $299 per entry. Our plot size was 5 by 20 foot, and these ended up being no-till planted in August. We were targeting the cover crop window that is typical for after small grain is harvested in Michigan. We did apply 30 pounds of starter nitrogen pre-planting to these plots, and the crop on the site previously had been forage soybeans. We did not apply any weed control other than the cover crop itself. Because of the variety of seeds that we had entered, we had small seeds and large seeds, so we set it up with 2 different planting depths so that we weren't compromising our small seeds by planting them too deep. 1/4 and 3/4 inch. And we did include those check plots for fallow. Here's a picture of this down in this lower picture. Here's our fallow plot with no cover crop planted. And we also included checks within our species group. So I'll talk about those when we get to the little bit of data. We were encouraging mixtures to be entered in this test. One of the criteria for the mixtures is that we will be reporting the actual percentage of seed by weight of each species in the mixture. And it's important that people remember when reading our reports that the proportion of seed in mixtures can change from year to year. So what might be in that company's mix this year is not necessarily the same thing that might be in their mix next year, which is why you need to pay attention to the proportions that are reported. This is what our site looked like on the 1st of September. So we had pretty good moisture on this site. There were parts of the state that were dry last year, but we actually were doing pretty good on this particular site. Here's what it looked like on September 17th, which was approximately 30 days after planting, and this is when the first cover crop or ground cover measurements and ratings were taken. This is what it looked like at 60 days after planting, and this was the date that the second set of ground cover measurements was taken. Now, just to get into the data a little bit, we did these ground cover measurements, and the way this works is we take a picture of the plots looking straight down on them, and the phone app will actually measure the percentage of green pixels in that picture. So this slide is showing some selected entries that were showing a range of ground covers. So this Ecotil radish had about a 97% ground cover. We would consider that a closed canopy because it's more than 95%. So you see very little soil here. That's very good. The Koga ryegrass at 94%, it's a little bit lower. Brassica rape, only 76% of the ground cover is plant. Lowboy ryegrass at 68%. Hairy vetch only 39%, and the taipan balanza at 12%. And this just shows you a range of the the extent of ground cover that you might be able to get within a very short period of time after planting, because this is 30 days. Here's what a couple of selected species from the previous slide shown how they progressed from 30 days after planting on the left to 60 days after planting on the right. On the Koga ryegrass, we actually had a numerical decrease in ground cover, but probably statistically not different. So that held its ground pretty well. The lowboy ryegrass increased quite a bit as it continued to grow, went from 68 to 94%. We had a few things that actually went backwards in that second 30 days. Some of the radishes and the turnips tended to start to go into some senescence because it was dry at that point. And this one dropped a little bit from 97 to 84%. Whereas some of these that were quite low at 30 days, like this hairy vetch, continued to grow, and by 60 days we were up to 90% ground cover. And it's giving us pretty good ground cover. And you can also see from these pictures that we're not seeing very many weeds in these plots. In general, our weed pressure was quite low on this site for reasons we are not quite sure about. So we didn't have a very good test of how well the cover crops would suppress weeds because we didn't really have a lot of weeds even on the fallow plots. Now, this test will have a report coming out in June that will have all the data in it. But all we have at this point in January is post-frost biomass that has been analyzed. And I put this up just as a example of some of the differences that we could see. The slide is set up with the top grouping is the 1/4 inch seeding depth, and then I have organized the entries into groups by type of plant. So we have our brassica family, our annual ryegrass, and our clovers. And across the bottom is the name of the actual variety. The ones that are shown in orange are the checks that we put in. And just to make things easier for people, these darker green ones in the brassica group are the radishes, since people are usually interested in those. And the ones marked with an F were 2 that were entered at a higher than recommended planting rate because those particular ones are intended as biofumigants, and the company requested that they be planted at a higher rate. Across the bottom, we have the 3/4 inch seeding depth group, which has our small grains, our legumes. There's 2 checks in there because one is a pea and one is the hairy vetch. And then our group of mixtures. And we used a turnip oat mixture as our check in that section. So what are we seeing here? This biomass was measured on November 7th, which was approximately 11 weeks after planting. That's when we had our killing frost. The error bars in the charts indicate the least significant difference. So if you look at within one of these sections, if you look at any two bars, if there's no overlap between that LSD bar, then there is a statistical difference in biomass between the varieties. So what you can see here is in Nebraska's, our control species was our lowest biomass, but the only two that were actually significantly higher than that were the control mustard and the Brassica forage rate. The rest of them, statistically, not much difference. The annual ryegrasses, not very much difference among them. Clovers, our Dixie Crimson Clover was better than all of the, this CW is a Berseem. The other two, Taipan and Viper, are Balanza clovers. Moving down to this one right here, the highest biomass we found in the whole trial was our Pratex, which was a black oat variety, which had quite impressive yields actually. Not much difference amongst our large seeded legumes, and surprisingly not a lot of difference amongst our mixtures, although the best mixture was better than the worst one. If you look at these numbers here on the x-axis, the 8x indicates how many species were in the mixture. So an 8x mixture had 8 species in it, a 10x mixture had 10 species, and so on. So there didn't really seem to be a lot of much of a trend here that more species in the mixture resulted in more yield. So we'll have to see what pans out in that when we look at other things such as ground cover when we have that data prepared. Be looking for that final report to come out in June, and it will be posted on this website here at the Michigan Forage Connection and in other places, no doubt. If you have any questions about any of this material, you can contact me at the email shown here. Thank you.